Hello, good morning, friends. Welcome back to your favorite channel, Code Digest. Today, in this video, we will discuss what is command design pattern, where to use command design pattern in our project. I'll also show the Java code implementation of command design pattern. At the end, we will also discuss the benefits of command design pattern. So stay tuned till the end of the video. Friends, in the previous video, we discussed about chain of responsibility design pattern. Can you explain what is chain of responsibility design pattern and where to use it? Please reply your answer in the comment section of this video. If you have not seen that video, I recommend you to go and see that video. It's a very important design pattern. The link of that video is given on your screen and also shared in the description section of this video. Just to recall, what is chain of responsibility design pattern? Chain of responsibility design pattern lets more than one object handle your request without mutual knowledge. For more information, please go and see the previous video. Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share and subscribe my channel so that I can grow Code One Digest family. Thank you. Okay friends, now let's start with the command design pattern. What is command design pattern? Command design pattern is a type of a behavioral design pattern that turns a request into a standalone object that contains all the information about the request. The transformation let you pass the request as a method argument, delay or a queue a request execution and support undoable operations. Command pattern is used to create objects that represent action and events in an application. A command object encapsulates an event and contain all the information required to understand exactly what has happened. The chain of responsibility pattern forward the request along a chain of a classes, but command pattern forwards a request only to a specific module. It encloses the request for a specific action inside an object and give it a known public interface. When you build a Java user interface, you provide menu items, buttons, and checkboxes, and so forth to allow the user to tell the program what to do. When a user selects one of these controls, the program receives an action event, which it must trap by subclassing the actionPerformed event. Command pattern allows a request to exist as an object. Friends, let's understand command design pattern with a real world analogy. You go to a nice restaurant and sit at the table a friendly waiter approaches to you and quickly takes your order. Writing it down on a piece of paper, a waiter goes to a kitchen and sticks the order on the wall. After a while, the order gets to the chef who reads it and cooks the meal accordingly. The cook places the meal on a tray along with the order. The waiter discovers that the tray, checks the order to make sure everything is there you wanted, and bring everything to your table. The paper order serves as a command. It remains in a queue until the chef is ready to serve it. The order contains all the relevant information required to cook the meal. It allows the chef to start the cooking right away instead of running around clarifying the order details from you directly. Let's discuss another example. Imagine you're working on a new text editor application. Your current task is to create a toolbar with a bunch of buttons for various operations for an editor. You created a very neat button class that can be used for button on a toolbar as well as for a generic button in various dialogues. Though all of these buttons look similar, they are all supposed to do different things. Where should you put the code for the various clicks handler of these buttons? The simplest solution is to create tons of subclasses for each place where the button is used. These subclasses would contain the code that would have to be executed on a button click. But sooner you realize that this approach is deeply flawed. First, you have an enormous number of subclasses, and that would be okay if you were not risking the breaking the code in these subclasses each time you modify the base class. Soon, UI becomes awkwardly dependent on a volatile code of a business logic. Friends, good software design is often based on a principle of separation of concerns, which usually results in breaking an app into layers. The most common example, a layer for a graphical user interface and another layer for business logic. The GUI layer is responsible for rendering a beautiful picture on a screen, capturing any input and showing the result of what the user and applications is doing. However, when it comes to doing something important like calculating the trajectory of a moon or composing an annual report, the GUI layer delegates the work to underlying layer of business logic. The command design pattern suggests that graphical user interface objects should not send these requests directly to the business layer. Instead, you should extract all the request details such as object being called, name of the method, and list of the argument into a separate command class with a single method that triggers the request. Command object serves a link between various GUI and business logic objects. From now on, the GUI object doesn't need to know what the business logic object will receive the request and how it will be processed. The GUI object just triggers the command which handles all the details. You can see the example on your screen that direct communication is not encouraged between the GUI to business. Command design pattern takes the request from GUI layer and then it will pass it on to the business layer. Now, the next step is to make your command implement the same interface. Usually, it has just a single execution method that makes no parameter. This interface lets you use various commands with the same request without coupling it to a concrete classes of commands. As a bonus, you can switch command object linked to the sender, effectively changing the sender's behavior at runtime. Okay, friends. Now let me show you an implementation of command design pattern in Java. Friends, I have written a code for you and I'll show you how can you implement the same in your project. Let me walk you through with the code first, then I'll run the code and show you the demo. This code is available also in a GitHub repository. You can download and play with it. The link of GitHub repository is shown on your screen and also available in the description of this video. So you can download the code and play with it. So let me show you what I have done. I have a command package where all my classes are there. Then I have defined one abstract class that is iExecute. It has two things here. One is string command and it has one abstract method execute command. Now I have implementation of this abstract class. Let's say open. Open file is one of the command. So in this open command, I have initialized the command with string open and in execute method I'm printing open command executed successfully. Same way in a file command, I have file as a command, file string as a command and message here file command executed successfully. Same way I have print and save. Then I have written one test class where I have defined a list of all my commands. And in that list, I'm adding all different type of commands, open, file, save, print. Now this list has all possible commands. Then at this moment, what I'm doing is in this method, I am passing a command. It can be open, it can be file, it can be print, or it can be save. Now I'm checking the list whether the command is available and available. If it is there, then I'm returning an object of that command. Once I got the object of that command here, then I'm executing that command because that command method is nothing but it's printing the command. So now what I'm doing is I am passing a string and here I'm matching if that command string is matching with any one of the command in the list, and if it is yes matching, then it is returning an object of that command. Now after returning, when the object is written here based on that string, then I'm calling the execute method. Let me run and show you how this works. So I'm doing it for open, printing the command, then executing the command, printing the file command, then executing the file command, then printing the save command and executing the save command, and so on. Yeah. So you see the command is open and it says open command executed successfully. The command file and file command is executed successfully, and so on. Right? So this is the beauty of command design pattern where your request and all the required information, you keep it in one object, and that becomes your command object, and then you send that command object to perform that action. So friends, when do you think you can use this pattern in your project? Whenever you want an action that can be represented in many ways, like drop down menu, buttons, and pop up, that time you can think of this command pattern. Whenever you want to create or redo functionality by reusing the code and command object, that time you can think of using command design pattern. So friends, what is the benefit we get out of this command design pattern? A command object is a possible storage for procedure parameters. It can be used while assembling the parameters for a functional call and allows the command to be set aside for later use. A class is a suitable place to collect code and data related to a specific action or event. It allows the reaction to a command to be executed sometime after it has occurred. Command object enables data structures containing multiple commands. Command object supports undoable operations provided that the command objects are stored. Okay friend, let me summarize what we learned in this video. We understood what is command design pattern. We saw real examples of command design patterns. We also saw Java code implementation of command design pattern. And then we saw use cases of command design patterns. At the end, we also discussed the benefits of command design pattern. So friends, let me know if you have already used this pattern in your project or seen a scenario where this pattern can be very useful. Please reply in the comment section with your answer. Friends, in the next video, we will cover state design pattern. We will see what is a state design pattern. We will learn what is the usage of a state design pattern. We will also see Java code implementation of a state design pattern, and we will also discuss the benefits of a state design pattern. So stay tuned till the next video comes, and do subscribe to this channel if you are new to the channel. Thank you. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications, and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners, and software engineers. I am putting a lot of efforts in creating these contents, so please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.